Okay, so to start off for this problem, we're going to look at part A, and it asks what the smallest period k0 that can be used to perform circular convolution is. So we know to find the length of an output signal, you take the lengths of the two signals that you're convolving and add them together and subtract 1. So that will give you a k0 that's equal to 4. And then for B, you're going to perform the circular convolution of these two functions using the k0 that you just calculated. So what you have to do first is get k equals 4 values in each of your signals. So for that you have to zero pad. So you get your periodic functions xp of k and hp of k. Then you just perform the circular convolution. So you write your xp of k down, which is 1, 1, 1, 0. And then you take your hp of k and you write it with a circular flip, and then you circular shift it 4 times. And then you add up all of your values to get your y of k. So that will give you a y of k that is equal to 1, 3, 3, 2. Now, in order to check that we have done the circular convolution correctly, part C asks us to calculate y of k by doing linear convolution. So you take each of your functions as they originally were, and you have x of k is equal to 1, 1, 1, and h of k is equal to 1, 2. And then you write out your x of k and h of k, and you be sure to line up your 0 indexes. And then you multiply each element of x of k times each element of h of k and shift it every time to compensate for your shift. And that would give you y of k is equal to 1, 3, 3, 2. Which, as you can see, is the same thing we got with the circular convolution. So we know that we've done our convolution correctly. And then to find our k equals 0 index, we can look at where our values line up for our 0 indexes for our two functions, and that will be our k equals 0 index.